NEC Article 620.21d addresses the location of the disconnect for elevator equipment. This section of the National Electrical Code is crucial for ensuring safety and accessibility in elevator systems. Specifically, it dictates where the disconnect switch for elevator equipment, excluding the driving machine motor or motors, must be situated. The code mandates that the disconnect be readily accessible. This means it should be easily reachable without the need for tools, ladders, or any obstruction that could impede quick access. Additionally, the disconnect must be located no more than 6 feet, which is equivalent to 1.83 meters from the door to the elevator equipment room or motor room. This proximity requirement is not arbitrary. It's rooted in safety considerations, primarily to provide a swift and straightforward means of disconnecting the power supply to the elevator equipment in emergency scenarios. Consider situations such as a fire within the elevator equipment room or, more critically, a person trapped inside the elevator car. In such instances, every second counts. The ability to quickly cut off power to the elevator system can be paramount in preventing further harm or facilitating a safe rescue. The 6-foot distance is a carefully considered balance. It's close enough to the entrance to allow for rapid access in emergencies, yet it provides sufficient space to prevent accidental or unauthorized disconnection. It's important to note the specific wording of the code, particularly the exclusion of the driving machine motor or motors. The disconnect requirements for the main driving motor might differ and are typically covered elsewhere in the NEC. This specific regulation focuses on the auxiliary equipment and control systems within the elevator setup. When installing or inspecting elevator disconnects, it's essential to precisely measure the distance from the door to the disconnect switch. Adherence to this code is not merely a matter of compliance. It's a fundamental safety measure that can have life-saving implications. Installers, inspectors, and maintenance personnel should be thoroughly familiar with this requirement to ensure the safe operation of elevator systems. The readily accessible aspect of the code is also important. The disconnect should not be hidden behind panels, obstructed by equipment, or placed in a location that requires special tools or knowledge to access. It should be immediately apparent and easily operable by authorized personnel during an emergency. Furthermore, proper labeling of the disconnect is crucial. The disconnect should be clearly marked to indicate which elevator equipment it controls. This eliminates any ambiguity and ensures that the correct power supply is isolated in an emergency situation. Regular inspections of the disconnect switch and its surrounding area are recommended. This includes verifying that the switch is functioning correctly, that the area around it is clear of obstructions, and that the labeling is still legible. Any deficiencies should be addressed promptly to maintain the safety and operational readiness of the elevator system. The NEC is a comprehensive document, and it's essential to consult the latest edition for the most up-to-date requirements. Codes and standards can change, so staying informed is vital for ensuring compliance and maintaining safety. The 6-foot rule for elevator disconnects is a seemingly simple requirement, but it embodies a crucial safety principle. It's a prime example of how the NEC strives to balance functionality with safety to protect both users and maintenance personnel. In addition to the distance requirement, it's also important to consider the type of disconnect switch used. The switch must be rated for the voltage and current requirements of the elevator equipment it serves. It should also be suitable for the environment in which it's installed. For example, if the elevator equipment room is subject to moisture or dust, the disconnect switch should be appropriately rated for those conditions. Furthermore, the disconnect switch should be lockable in the open position. This allows maintenance personnel to safely work on the elevator equipment without the risk of the power being accidentally restored. Lockout-tagout procedures should always be followed when working on electrical equipment. The NEC also addresses the requirements for the branch circuit supplying the elevator equipment. The branch circuit conductors must be sized to carry the load of the equipment, and they must be protected by an overcurrent device such as a circuit breaker or fuse. The overcurrent device should be sized to protect the conductors and the equipment from overloads and short circuits. Grounding is another critical aspect of elevator electrical systems. All metal parts of the elevator equipment, including the disconnect switch enclosure, must be properly grounded to provide a path for fault current to return to the source. This helps to prevent electrical shock hazards. The grounding conductor should be sized in accordance with the NEC. In some cases, the elevator equipment may require a dedicated equipment grounding conductor. This is a separate grounding conductor that runs directly from the equipment to the grounding electrode system. A dedicated equipment grounding conductor can provide a more reliable grounding path than relying on a metal conduit or raceway. The NEC also addresses the requirements for emergency power systems for elevators. In many jurisdictions, elevators are required to have an emergency power system that will automatically provide power to the elevator in the event of a power outage. This is especially important for elevators that serve hospitals, nursing homes, and other facilities where people may be dependent on the elevator for mobility. The emergency power system should be capable of providing power to the elevator for a specified period of time, typically at least 1 hour. The emergency power system should also be tested regularly to ensure that it is functioning properly. The location of the elevator equipment room should also be considered when installing the disconnect switch. The equipment room should be located in a safe and accessible area. It should be protected from fire, water, and other hazards. The equipment room should also be adequately ventilated to prevent the buildup of heat. The elevator equipment should be installed in accordance with the manufacturer's instructions. The instructions should provide detailed information on the installation, operation, and maintenance of the equipment. It is important to follow the manufacturer's instructions carefully to ensure that the equipment is installed and operated safely. Regular maintenance of the elevator equipment is essential for ensuring its safe and reliable operation. The maintenance should be performed by qualified personnel who are familiar with the elevator equipment. The maintenance should include inspecting the equipment for wear and tear, lubricating moving parts, and testing the safety devices. Any deficiencies should be addressed promptly. In addition to the NEC, there may be other applicable codes and standards that govern the installation and operation of elevators. These codes and standards may vary depending on the jurisdiction. It is important to consult with the local authorities to determine the applicable requirements. The information provided here is intended for general guidance only and should not be considered a substitute for professional engineering advice. Always consult with a qualified electrical engineer or inspector before installing or modifying any electrical equipment. The NEC is a complex document, and it is important to have a thorough understanding of its requirements before working on any electrical system. Continuing education is essential for staying up to date with the latest codes and standards. There are many resources available to help electrical professionals stay informed, including seminars, workshops, and online courses. By staying informed and following the NEC, electrical professionals can help to ensure the safety and reliability of electrical systems. The purpose of the NEC is to protect people and property from electrical hazards. By following the code, electrical professionals can help to create a safer environment for everyone. The NEC is constantly evolving to keep pace with new technologies and changing safety needs. It is important to stay informed about the latest changes to the code. The NEC is a valuable resource for electrical professionals. It provides guidance on how to install and maintain electrical systems safely and effectively. The NEC is a living document that is constantly being updated to reflect the latest advances in electrical technology. It is important to stay informed about the latest changes to the code to ensure that electrical systems are installed and maintained in accordance with the most current safety standards. The NEC is not just a set of rules. It is a comprehensive system of safety standards that are designed to protect people and property from electrical hazards. By following the NEC, electrical professionals can help to create a safer world for everyone. Firstly, the disconnect must be readily accessible. Secondly, the disconnect must be located no more than 6 feet, or 1.83 meters from the door. Thirdly, the disconnect should be clearly labeled.